This is Case Tools Lab exercise number 2. In this exercise we are going to see how to draw a class diagram. So here, class diagram identify the class structures of a system, including the properties and methods of each class. It specifies the various relationships that exist between the classes, such as an inheritance. The important point about using a class diagram is the components on a class diagram are classes and the relationship between them. So here we are going to use an example of hospital management system, and we're going to draw a use case diagram for it. A class is depicted using a rectangular divided into 3 sections. The top one is the name of the class, the second one is the attribute, and the third one is the methods that are present in the class. There are 3 relationships. One is association. An association is a generic relationship between 2 classes and is modeled by a line connecting the 2 classes. This line can be qualified with the type of relationship. So the syntax for that is we have 2 classes here, that is person and magazine, and there is a simple line drawn towards both of them. This is called association. Then we have aggregation. Aggregation indicates a whole part relationship and are known as has-or relationships. An aggregation relationship is indicated by a line with a hollow diamond. So this is how the syntax looks like. Composition is a class. If a class cannot exist by itself and instead must be a member of another class, then the class has a composition relationship with the containing class. So the way how this composition classes can be represented is by using a line with a filled in diamond symbol. Dependency. It exists between 2 elements. If changes to the definition of one element may cause change to the other. This association is unidirectional. The dependency relationship is indicated by a dotted arrow, as you can see here. Generalization is a relationship and equivalent of in a relationship in object-oriented terms. A generalization relationship is indicated by an arrow with hollow arrow head pointing towards the base or parent class. So you can see the syntax here, that is there is a parent and it has got 2 children, that is student and professor, and by using the generalization dependency we can pictorially represent this. Then we have realization. In UML modeling, realization relationship is a relationship between 2 model elements in which one model element realizes that the other model element specifies. So the way how this can be depicted is using a dotted line with a triangular arrowhead in the end. So here, as I said, we are using a hospital management as an example to draw the use case diagram. This is how the use case diagram looks like using all the dependencies. Now let's see what are all the class names and the attributes and methods that are inside the classes. We have a class called patient, and it has got an attribute, that is member ID, and a method check exist. So attribute means they are the variables which are inside the class, and methods are the functions that are used inside the class. The second one is membership. So in the membership we have ID, register number, name, date of birth, address and phone number. Also one method called age calculation, which will calculate the age of a person using the date of birth. And the next one is admission. In admission we have attributes like ward, room number, bed number, nurse and discharge, and also a functionality called number of days, which will calculate the number of days the patient stays in the hospital. Then there's another class called hospital, which contains records as its attribute, and annual income is being calculated by adding up all the transactions that happen in the hospital. Then bill is another class where the total and the status, that is status, which means the bill is paid or not paid. And also we have one attribute called add total, which will keep on adding all the bills together and finally produce one grand total. We have medicines and lab as another individual class, which consists of names of all the medicines, and then there are 2 classes, the 2 functions called get medicines and get tests, which will actually contain of all the medicines and tests that are being taken. Then the final class is operation. So in the operation we have appointment, surgeon and report as the attribute, and there are 2 functions called instruments and equipments, which will contain all the instruments and equipments used during the operation. So let us see the dependencies that are there between these classes. There is a patient class and membership class. So patient and membership are directly associated with each other, whereas hospital management takes in control of all these membership. So if there is no hospital, then there is no membership. It is a kind of a parent class. Then we have admission, bill, and the medicines and laboratory and operation. If the bill is not paid, then no admission can be done, as well as no operation and no medicines can be bought. Whereas, and the same way, if there's no membership also, no admission can be done and operation cannot be done. But then here, as you can see here, I've used the aggregate function where medicines and lab, if somebody is from outside and they need to get the medicine, it need not mean that they should have a membership. They can also buy the medicine without having a membership. So this is the end of the program. Thank you.